Okay, good morning students. So today we will continue the second kind of improper integral. So first kind of improper integral we have studied, that definition of gamma function, properties of gamma function, and how to evaluate gamma function. So the next one, continue with the beta function. Now start with the definition. Just a minute. Suppose definition of a beta function. Suppose for the definition I will continue with. So in the same manner I will write an integral. Suppose I will write the integral, see the difference. Integral from 0 to 1. What is the first difference? In the first gamma function, you are having that limits of the integral from 0 to infinity. Infinity is there. But in this case, you are having the limits from 0 to 1. That is a finite range is there. And integrand is defined by some x raised to m minus 1 into 1 minus x raised to n minus 1 dx. And when you take evaluation of this integral, once again these integrals define a function of some variable. This integral defines function of some variable. So actual procedure tells us that you have to evaluate the finite integral, and at the end you have to substitute x is equal to upper limit and x is equal to lower limit, their subtraction. Now can anyone tell the evaluation of this integral depends on which variables or parameters? What are the parameters remain same up to the end? Because in beta in gamma what happens? Integral 0 to infinity e raised to minus x into x raised to n minus 1 dx. Now in this case this defines gamma of n. This defines gamma of n. We are writing this gamma of n because there is only one parameter. Okay, this is improper integral of the first kind. In the same manner, if you go for the second one, that I have defined as a limits from 0 to 1 x raised to m minus 1 into 1 minus x raised to n minus 1. Now this integral depends on which parameters? Yes, Prerna, can you tell?
X and N.
No. Finally, remember what I am telling. At the end, you have to substitute limit for x. Means when you substitute x is equal to 1, whatever expression you are getting, that is free from x nasna rahe. And at the same time, you have to substitute x is equal to 0. Okay. So that integrals defines function of some another variable x will not be there. Yes, can you correct your answer?
M and N.
Yes, very good. In this case, you are having the two parameters m and n. So this defines a function of the two parameters, and these parameters are m and n, and it is called as a beta function. It is called as a beta function, and it is denoted as beta of m and n. So beta of mn is defined by the improper integral, or we can say definite integral, limits from 0 to 1 x raised to m minus 1 into 1 minus x raised to n minus 1 dx. Okay, and this integral is defined for the parameter m is greater than 0 and n is also greater than 0. And suppose this as a number 1. Suppose I want to write a complete definition, then the function, it defines a function, the function, and this function is denoted as a beta notation. What is its domain? Its domain is a ordered pair. One is m, second is n, and the ordered pair is given by the cross product of r plus to r plus, means these are the positive real numbers. And when you evaluate the integral, that defines, or that is a real number. So it is a function from r plus their cross product. So defined by the rule. So it is defined by the rule. What is the rule? That rule is given by the integral 0 to 1 x raised to m minus 1 into 1 minus x raised to n minus 1 dx, where m and n are positive real numbers. If you are taking the negative, then don't take negative integer. For others also it may define. Okay, and which is called as beta function, which is called as beta function. Now in the same manner, these are nothing but the integral, special kind of integral. If you define the limit and kernel, that convert to the second form. So in case of a gamma function, we have seen the kernel is nothing but e raised to minus x. Means if you are reducing a particular integral to the gamma function, our main target is e to the power minus x. Now in this case, if you are reducing this integral to beta, limits are 0 to 1, and if you are trying to reducing that integral to the beta, then in this case the kernel is 1 minus x, that is the parameter. Again we consider the property that definite integral is independent of the parameter. That's why, so here I may write the definition of beta mn as, so that beta mn as, first one I will take as it is, definite integral 0 to 1 x raised to m minus 1 into 1 minus x raised to n minus 1 dx, that is the first one. Second, by using the property of definite integral, definite integrals are independent of the parameter. That's why this same integral we may write 0 to 1 some t raised to, I am changing parameter, so that variable x to t raised to m minus 1 into 1 minus t raised to n minus 1 dt. So what you are doing here, simply you are using the substitution x equal to t, if you required for in your language. Suppose this one, y raised to m minus 1 into 1 minus y raised to n minus 1 dy. Again some variable, whichever you want to write. So 0 to 1 some p raised to m minus 1 into 1 minus p raised to n minus 1 dp. Okay, so while solving the example you can refer any one. So all integral defines the beta function. Now next we will see the properties. So in the same manner, for gamma also we have seen the properties of beta function. Properties of beta function. Now the first property states that beta of mn, first property says that beta of mn is equal to beta of nm. Means what? If you are changing the role of m and n, again the evaluation of integrals is same. Suppose you want to define or you want to prove this. Now I will start with the definition. Suppose, so by definition, actually this part is not expected, but still I am taking. By definition, beta of mn is given by integral 0 to 1 x raised to m minus 1 1 minus x raised to n minus 1 dx. And suppose this integral you are reducing to the beta of nm, and by definition this is nothing but 0 to 1. Suppose some t raised to n minus 1 into 1 minus t raised to m minus 1 dt. So from this, if we compare these two integrals, can you guess what will be the substitution for x? I will highlight. From that you can guess x, and here 1 minus t. Yes, Puneet, what is the substitution I have highlighted? Put. Yes, quickly. So here you have to put x is equal to 1 minus t. That is your substitution. Okay, so that is your substitution. So that integral you have to convert in terms of t. So for that, differentiate both sides, you will get dx is equal to minus dt. So differentiation of 1 is 0, differentiation of t is minus 1. Now the limits. So given limits for, suppose in the table form I will write 0 and 1. So what is the value of t? When x is equal to 0, t is, this substitution, the same thing you may write as t is equal to 1 minus x. Is it right? T is equal to 1 minus x. Now substitute x is equal to 0, then what is t? Aditya Patil, you have to substitute the value of x as a 0. Then what is t?
1.
Yes, it's 1. I think some students are sleeping because of rainy season. Aditya Patil, next one. If x is equal to 1, what is t?
0.
It is 0. Okay, so new limits for the integral is 1 to 0. Okay, 1 to 0. So further we require 1 minus x factor, that I will calculate. So consider this 1 minus x. That means 1 minus, that value of x is 1 minus t. Okay, if you simplify, what is the value? 1 and minus 1 get cancelled, t and minus t, it becomes t. Is it correct? Little bit I will score. Therefore, so if required, you can write the table here in the table form. These are the limits. Okay, now the integral beta mn, that definition once again I will write. Beta mn is given by new limits from 1 to 0. Remember, new limits from 1 to 0. The value of x I will substitute as 1 minus t raised to power is m minus 1, and 1 minus x, just you obtain that value as a t raised to n minus 1, and dx is nothing but minus dt. Now this negative sign I will absorb to change the limits of the integral. This is given by integral 0 to 1, and what I will do, this negative sign I will absorb and I will alter the terms. That can be written as t raised to m minus 1 into 1 minus t raised to, something is wrong, 1 minus t raised to, first one is just a minute, this is n minus 1, first one is n minus 1, and this one is m minus 1 and dt. And if you refer the second definition, what it defines?
Beta of m and n.
Beta of n and m. Okay, it is beta of n and m. So thus the first property is beta of mn is equal to beta of nm. That means as per your convenience, you can change the role. Beta of mn is equal to beta of nm. Now the second property is a relation between beta and gamma function. Second one is a relation between beta and gamma function. Beta and gamma function. Now see, to prove this result, first I will write the property beta of mn can be written in terms of gamma as gamma m into gamma n divided by gamma of m plus n. Okay, and further that right side you can simplify by using a definition of gamma function. So to prove this property, we required some result from the double integral, and double integral is the next unit. If time permits, in double integral we will see the proof of that. Now here, for evaluation of a beta function, you have to accept the second result, beta of mn is equal to gamma m into gamma n divided by gamma of m plus n. Okay, now the third property, we are not taking the proof of this. Third property, beta of mn, this is also known as a second definition of a beta function. This is also known as second definition of beta function. That means the integral defined in terms of the trigonometric terms and how it can be converted to beta. So beta of mn is given by 2 times integral from 0 to pi by 2. Integral from 0 to pi by 2. That integrand is combination of sine and cos. Sine theta raised to 2m minus 1 into cos theta raised to 2n minus 1 d theta. Okay. Now let us continue with the first of our beta function. Solution for this or proof for this. We know that beta of mn is given by integral 0 to 1 x raised to m minus 1 into 1 minus x raised to n minus 1 dx. Now if you compare the given integral, that means the limits we are having 0 to pi by 2, the integrand is a combination of sine and cos. Now in the required integrals you are having a two term, one is sine theta, one is cos theta raised to some power. And in the given integral you are having one term as a x and another term as a 1 minus x. Can you guess a suitable substitution for x such that that two terms x and 1 minus x can be converted as a sine and cos, or vice versa, cos or sine? Yes, anyone? This question is open to all. What will be the substitution? I have to repeat the question. Once again, can you repeat what is your substitution? Put x is equal to sine 2 theta.
Yes, sir.
Okay, your substitution I will write here. X is equal to sine 2 theta. Then what is 1 minus x? It can be converted to cos?
Yes, it's 2 cos square theta.
It not works. Any other suggestion? It not works. Any other suggestion?
Equal to sine square theta.
Yes, very good. You have to put x is equal to sine square. You are having that identity, na? You are having that identity. 1 minus x square, 1 minus sine square theta is. So that's why. So you have to put x is equal to sine square or cos square. Both works. So put x is equal to sine square theta. Okay, put x is equal to sine square theta. Then what is your dx? What is your dx? 2 sine theta into cos theta d theta. Is it right? Dx is 2 sine theta into derivative of sine theta is cos theta d theta. Okay. Now, suppose the given limits are given x is equal to 0 and x is equal to 1. Then what will be the theta? So for what value of sine is 0? For what value of theta sine is 0? Quickly. Natharu, for what angle sine is 0?
0.
Yes.
Sine 0
is 0. Barabar. For what angle sine is 1?
90.
90. That can be written as a pi by 2. And that are the required results. If you refer the required results that are given by 0 to pi by 2, you are getting the required limits 0 to pi by 2. Now 1 minus x. Now this 1 minus x factor can be written as 1 minus sine square theta, and 1 minus sine square is cos square theta. Now what I will do, all these values I will substitute in the given integrals. Therefore this beta of mn is given by given limits 0 to 1, new limits 0 to pi by 2. X is nothing but sine square theta raised to m minus 1. Okay, so 1 minus x is cos square theta raised to n minus 1, and dx is nothing but 2 sine theta into cos theta d theta. Okay, 2 sine theta cos theta d theta. So from this I think next is the required answer. This 2 I will take outside the integral. This is 2 times integral from 0 to pi by 2. So tell me sine theta raised to effective power. So here you are having 2m minus 1 and 2m minus 1 means 2m minus 2. Here I will write 2m minus 2 and plus 1 means what it will come? 2m minus 1. In the same manner, if you collect cos term, it is 2n minus 1 d theta, and this we consider as the second definition of beta function. This we consider as a second definition of beta function. Okay. Now the third one, So by using second definition of beta function, how to evaluate the integrals if they are given in the trigonometric form? That is the fourth property. Fourth property is in terms of beta. Suppose integral 0 to pi by 2, integral 0 to pi by 2, I will use black pen, that similarity I have to maintain that statement. Integral, you can use prove that statement. Integral from 0 to pi by 2. So what I am doing here, simply sin theta raised to some power cos theta raised to some power d theta, and which is given as 1 by 2 beta of p plus 1 divided by 2, that is the first parameter, beta of q plus 1 divided by 2. Can anyone tell what we have to do here? That answer is in front of you. Yes. Meanwhile, I will write the statement earlier. We know that beta of mn is given by 2 times integral 0 to pi by 2 sin theta raised to 2m minus 1 into cos theta raised to 2n minus 1 d theta. So if you compare both the integral, because in beta definition we don't have p and q, if you compare both the integrals, so what we have to use the substitution or values? Yes, Kavita?
Don't know, sir.
Compare both the integrals. Don't directly state forward why or telling don't know. If you compare, otherwise I will highlight the particular term. So this 2 can be adjusted anywhere. Okay. This power, this power, this power, this power. Directly will get the answer, na? What you have to do then?
P is equals to 2m minus 1.
Yes, very good. 2m minus 1 is equal to p and 2n minus 1 is equal to q. Means what? From this you can calculate the value of m. The value of m, someone Pratmesh, and value of n from these two. Yes. Just a minute, I am getting call. Any urgent call is there, I will take that. Huh? Just 1 minute. Okay, continue. Now from this, what is the value of m? Quickly. Just you have to Pratmesh, you should be ready with the answer, na? Okay, Prerna, continue.
P plus 1 by 2.
P plus 1 divided by 2, and value of n is
Q
plus
plus
1
1.
divided by 2. Therefore, the given integral, I will continue with the right side. I will continue with the right side. So this can be written as, then the given integral can be written as, then integral, the limits remain same, 0 to pi by 2 sin theta, 0 to pi by 2 sin theta raised to 2m minus 1 and cos theta raised to 2n minus 1 d theta. This 1 by 2 I will adjust to the left side, and 1 by 2 into beta of p plus 1 divided by 2 q plus 1 divided by 2, and I think that is the required answer. Required answer, just check it. Is it right? Okay, continue the next one. Any doubt up to this? One is the next property. So this property we will use to evaluate the integrals. We will use to evaluate the integral. Okay. Now continue the next one. Now the same integral we will write in terms of the gamma function. That means integral 0 to pi by 2. Now this proof I will not write, because simply you have to use the property that is the relation between beta and gamma function. Integral 0 to pi by 2 sin theta raised to p. Something I written wrong in the earlier case. Cos theta raised to d theta. Can anyone identify what I written wrong? 1 by 2 into gamma of p plus 1 divided by 2 gamma of q plus 1 divided by 2 the whole divided by gamma of, yes, anyone, plus q plus 2 divided by 2. Simply here I am using relation between beta and gamma function. Here I have to write raised to and q. Here I have to write raised to p and raised to q. And simply to prove this relation, I have to use the property beta of mn 1 by gamma m into gamma n divided by gamma of m plus n. Gamma of m plus n. That's why that property you can apply. Now the sixth one, some particular property, that is gamma 1 by 2, that we accepted in gamma function. Gamma of 1 by 2 is given as root of pi. Gamma of 1 by 2 is given as a root pi. Now to prove this result, I will continue with this integral. So we know that integral from 0 to pi by 2 sin theta raised to p into cos theta raised to p theta is given by 1 by 2 into gamma of p plus 1 divided by 2 gamma of q plus 1 divided by 2 that whole divided by gamma p plus q plus 2 that whole divided by 2. Okay, this is the property. Now in this property, what you have to do, you have to put both p and q is equal to 0. P is equal to q is equal to 0. Then the integral becomes 0 to pi by 2. 0 to pi by 2. Both p and q are 0 and anything raised to 0 is 1. It becomes d theta, and which is given by 1 by 2 into gamma of 1 by 2 gamma of 1 by 2 divided by, what is it? Anyone? Both p and q are 0 na, gamma 2 divided by 2. The same thing, a little bit. So same thing, this one I will write 1 by 2 into gamma of, just I have to write gamma of 1 by 2. This is gamma of 1 by 2, it's a square, is equal to, now this is a definite integral with integrand as a 1 and limits 0 to pi by 2. So it evaluation is nothing but upper limit minus lower limit directly, no need to evaluate separately. So it is pi by 2 minus 0, and from this that 1 by 2 get cancelled, and you are getting gamma of 1 by 2 square is equal to pi. So taking square root on both sides, now you will get gamma of 1/2 equal to root of pi. Gamma of 1/2 equal to root of pi. That is a fourth property. In gamma function, without proof, you have accepted that. Okay. And one more is there. Next one is the duplication formula. Again, for the duplication formula, we are not going to study the proof. We have to accept that for evaluating a particular gamma function, that is gamma of 1 by 4 into 3 by 4. So duplication formula. Name of the result is formula for gamma function. So it is given as 2 raised to 2m minus 1 into gamma 1 into gamma of 1 plus 1/2 is given as root pi into gamma of 2m. So this result you have to accept. Okay. The proof of this result I am not taking because it is lengthy. For examination also that proof will be not asked. So one task I will give, and I will take 2 minutes break here. Note, in the above result, means in the duplication formula, what you have to do, put m is equal to 1 by 4 and try to obtain the product of gamma 1 by 4 and gamma 3 by 4. Take 2 minutes break. I will take 2 minutes break and try to complete that. Suppose we will simplify it. Then what will come? It is 2 raised to, at least tell me power, that simplification. What is 2m minus 1? Yes, anyone. What is 2m minus 1? 2m is 1 by 2 minus 1. What is the value?
Minus 1 by 2.
Yes. Next one is gamma of 1 by 4. Next one. At least addition, subtraction, that part you have to do, na? M plus 1 by 2.
Three by four.
Gamma of 3 by 4. This root pi remains as it is, and 2m is gamma of 1 by 2. Now further, if you simplify, this is gamma of 1 by 4 into gamma of 3 by 4 is equal to this term I will take to the right side. Then it becomes power as a positive. So it becomes 2 raised to 1 by 2 into root pi as it is. Gamma 1 half is again root pi. And if you simplify, 2 raised to 2 by 2 is root 2 into root pi. That means what is the evaluation while solving the example? If you are getting the product gamma of 1 by 4 into gamma of 3 by 4, so directly you have to reply something. I made mistakes. You should point out that.
It is only pi.
Yes, it is only pi, because root pi multiplied by root pi, it is only pi. Very good. Okay. So that is a next. You can consider this as also a property. So while solving the numericals, if such type of evaluation if you are getting, so that you have to replace. So this is all about the properties. Once again I repeat. So first one, you have to remember the definition of beta function. So beta mn is given by integral 0 to 1 x raised to m minus 1 into 1 minus x raised to n minus 1. Again, you can use the property of definite integral. You can replace the parameter x by t, t by y, y by p. And first property says that beta mn is equal to beta nm. That means the parameter m and n you can change. Second is nothing but the relation between beta and gamma function. Beta mn is given by gamma m, gamma n divided by gamma of m plus n. Now second definition, we treat this as the second definition of gamma function, and from this, what is the use of this? If the integrals are given in terms of the trigonometric terms, integral 0 to pi by 2 sin theta raised to p into cos theta raised to q. See, the nature of the integral is limits are from 0 to pi by 2. The integrand is combination of sin and cos, sin theta raised to some power into cos theta raised to some power. So that can be evaluated in terms of beta as well as in terms of gamma. Okay, so from that we obtain already we are using the result that gamma 1 half is root pi. So that result we have proved by using definition of that beta function, second definition, and a duplication formula to obtain the value of gamma 1 by 4 into gamma 3 by 4. So, okay, hope that there is no any doubts. We will continue with the examples. So type wise example I will discuss here. That is example 1, and this we may consider as a type 1. You have to remember the substitution accordingly. Type 1. To evaluate, the question is evaluate integral 0 to a. Instead of evaluate, I will give prove that. Means standard results I will give prove that. Prove that 0 to a x raised to m into a minus x raised to n dx is given by a raised to m plus n plus 1 beta of m plus 1 and n plus 1. Okay. Now first step I will call the integral, and after that I will discuss. Okay. So let I is equal to integral from 0 to a x raised to m into, sorry, this is a minus x raised to n dx. Now side by side I will write a definition in terms of t. So beta mn is given by, you should remember this, integral 0 to 1 x raised to m minus 1. Little bit I will write up, it may not come in the screen. Okay, so here I will write, I think this one is visible. Beta mn is given by integral 0 to 1 t raised to m minus 1 into 1 minus t raised to n minus 1 dt. Now I will highlight term. When you are converting an integral to the beta, our main target is to obtain 1 minus t. Purposely I have taken another variable, 1 minus parameter. Now by trial error method or by comparing both integral, you have to guess a substitution for x such that by using that substitution we will get 1 minus t factor. I will highlight the term. Can you think on this? Yes, Aditi. Here it is dx. Huh? What is the substitution? Put. Aditi, are you in the class? I am asking very difficult questions. What is the substitution? I think I am not connected with the class. I hope that. So here I required x is equal to 1 or something substitution you have to consider. What is the substitution? Put x is equal to 80. Put x is equal to 80. Then that dx is given by a times dt. Okay, limits. Given limits for x from 0 to a. Then when you substitute, I understood your attitude, all class attitude. Okay. So when you substitute x is equal to 0, then you will get a t also 0. And when you substitute x is equal to a, then you will get t is equal to 1. That means new limits for t is from 0 to 1. So further I required a minus x. That factor also I will calculate. Now this a minus x is given by a minus 80. So from that a I will consider outside. You will get 1 minus t. Now here, so I am getting 1 minus t factor. Okay. Therefore, the given integral I can be written as new limits from 0 to 1 that we required for the beta. X is nothing but 80 raised to m. A minus x is nothing but a into 1 minus t raised to n. Dx is given by a into dt. Now from all these terms, I will take a as a outside. The constant a term that is written in the multiplication form. So that term I will take outside, which can be written as a raised to m plus n plus 1. And the remaining terms are 0 to 1 t raised to m into 1 minus t raised to n, 1 minus t raised to n and dt. Now for beta, what is my requirement? The limits from 0 to 1 and kernel that is there. So that's why it defines a beta function, and to write the parameter you have to make the adjustment. This can be written as plus 1 minus 1. This can be written as plus 1 minus 1, and it defines beta of the first parameter is and beta of the second parameter is. Okay, so it defines I is equal to a raised to m plus n plus 1 into beta of m plus 1 into n plus 1, and that is the required result. I is equal to, that is the required result. That is the first example or first type. Second type, 3 types I will cover first. Second example, and that we can consider as second type. Example 2, that is nothing but type 2. To prove that integral 0 to 1 x raised to m into I highlighted that term. 1 minus t I required. So what you have to substitute? Directly put x raised to n is equal to t, na? Put x raised to n is equal to t, or x is equal to t raised to 1 by n, taking nth root on both sides. So this implies, by differentiating, dx is given by 1 upon t into t raised to 1 upon n minus 1 into dt. Okay, now the new limits, given limits for x. For x, limits are given as a 0 to 1. What are the limits for t? If x is equal to 0, t is obviously 0. If x is equal to 1, so nth root of 1 is again 1, means you are getting the same. Therefore, that integral I can be written as new limits 0 to 1, x is t raised to 1 upon n raised to m, and this becomes 1 minus t raised to p, that dx is given by 1 upon n into t raised to 1 upon n minus 1 dt. So from this I will take 1 upon n as outside this term, that can be taken outside the integral. Now for the remaining integral 0 to 1, first I will consider t to the power. What is the power? So here m by n, now here this one power. Base is same, by using the law of indices it can be written as m by n plus 1 by n minus 1 into 1 minus t raised to p and dt. I think it defines a gamma function, sorry, beta function 1 upon n. It is a beta of, what is the first parameter? I will highlight something minus 1. This is the first parameter. So beta of m plus 1 divided by n. And what is the second parameter? Anyone can guess?
P plus 1.
Yes, it is p plus 1. It can be written as plus 1 minus 1. So it is a gamma of this one. So here I have to write minus 1. Further, only thing you have to write that answer in the gamma form. By using relation between beta and gamma, this can be written as gamma of m plus 1 divided by n into gamma of p plus 1. That same thing we are getting now? Yeah, that same thing. Divided by gamma of m plus 1 divided by n in plus p plus 1. So this is the evaluation of the integral that you have to prove the second type. So where you are substituting x raised to n is equal to t. So one more type I will cover and I will stop. Third one, third example and third type. This one you can consider as a type 3. Prove that. Prove that integral 0 to 1, integral 0 to 1, 1 minus nth root of x raised to m dx can be written as m factorial n factorial divided by m plus n factorial. Now can anyone guess what is the substitution? Meanwhile I will write the integral. So let I is equal to integral 0 to 1, 1 minus nth root of x. Our target is to obtain 1 minus t raised to m dx. So what is your substitution? Put nth root of x is equal to t. That means x is equal to, yes, anyone? Taking nth power on both sides. So this implies dx is equal to n into t raised to n minus 1 dt. So again I think limits remain same. X is equal to 0 and 1, then t is also 0 and 1, they remain same. Therefore that integral I becomes new limits 0 to 1, 1 minus t raised to m dx is given by n into t raised to n minus 1 dt. So from this I will take n as outside, limits from 0 to 1, limits from 0 to 1, t raised to n minus 1 into 1 minus t raised to m, and this I will write plus 1 minus 1 dt, and that defines as a beta. So it can be written as n into beta of n and m plus 1, beta of n and m plus 1. So further, if you use the property, it can be written as n into gamma of m plus 1 divided by gamma of m plus n plus 1. Okay, so this all together, this can be written as a n factorial. So gamma m plus 1 is nothing but m factorial divided by m plus n factorial. So that is the evaluation. Okay, now here I will stop. Next lecture I will continue with the further example. So still I have to take the attendance. Wait for that. So today we have seen definition of beta, properties, and 3 types of integral, how to evaluate by using beta function.